recording. You guys hear me all right? Okay, cool. So this is the end of week 4. I want to start by doing a little bit of scheduling and bookkeeping stuff. So the current plan, we have 3 classes left. Right now, you should be doing Lab 4 and Homework 4, which is the Scratch Lab and the homework. And in a minute, I'll ask you guys if you have any questions or problems on that. And I'll spend a bunch of time going over that today. Next week, and maybe today, depending on how far we get, we're going to do designing algorithms and how it works and how to look at an algorithm and how to create an algorithm and how to analyze an algorithm, see if it's good or not, and that sort of stuff. This will be week 5's lab and homework. Because of the summer scheduling stuff, I guess I'll say this. Also, next week, the final. The final is going to be take home. The final is going to be mainly looking a lot like the homework problems. It's there for you to show me what you know about what we've done so far, that kind of thing. The registrar tells me that my last day to hand in grades is, so this week today's the 9th. Next week, the last actual class will be the 16th. So the Tuesday of the following week is the day I've got to get all of these grades into the registrar for everything to be done. So what that means is you need to get me everything I need to grade the day before. So next week's the regular week, and you're going to get the new stuff. Monday of the week after that is when you're going to have to get me everything handed in so that I can spend my Tuesday grading it so that I can get all of the grades in on time to make sure you actually get credit for this course, which would probably be a good thing for you guys. What I'm going to do is I'm going to put up the lab and homework 5 and the final today, but you may need next week to understand it. In other words, I'll put it up so that if you want to start early, you can start early and do as much as you can, but keep in mind that some of the stuff on that lab and on that homework is going to get explained in next week's lectures, so you may want to wait and see if you're confused about stuff, you may want to wait and see if it gets explained in the lectures, I guess is what I'd say. So that's the plan for till the end of the semester. We got about a week and a half left to go before everything's handed in, and you can forget about this stuff for the rest of your lives. That plan makes sense? Any questions on the plan? All right. For today, what I was going to do today is go over the whatever Scratch questions you had. Hopefully, you guys have at least started the lab, and answer any questions you have about things you're confused about in the lab. Maybe give you a couple of possible issues that you may run into, do in the lab, and then when time runs out, I'll get a head start on the next week algorithm stuff, so you have an idea if you want to jump ahead and start early. So, do you guys have any questions on Scratch or the lab or the Scratch homework or anything like that? Not for now. If you have not started it, make sure you start it soon, because you want to give yourself time to understand the interface and how it works and things like that before time goes on. So let me show you a couple of things to kind of keep in the back of your head while we are doing this. So when you log into Scratch, you get My Stuff, which is a window of all your projects and things like that. Some projects are shared, which means other people can see them. And then I get links to how many people have seen them, and the answer is 2, although 6 people have seen the Button Move program, so that's good. Some programs are not shared. Not shared means nobody else can see them, obviously. When you hand in the program, you need to make sure that you share it, so that I got a message. Let's see what it is. Okay. You need to make sure you share the program, so that, with me at least, so that I can see it. Otherwise, I won't be able to see the stuff you do, and I won't be able to grade it. Okay? So, first and most importantly, when you write this and you're done, make sure you share it with me, and the way you and so that I can see it. And the way you share it is you make a new project, and then you wait, and then the cat shows up. And I don't know, say, make a little stupid program here. Say, this is an awesome program. And so when I click the green flag, he says, "This is an awesome program," for 2 seconds, and he stops talking. The share button's right here. It's right next to the See the Project page. You click that share. It is now available for everybody to see. It'll show you the kind of page that will show up, that everybody look at. It'll show up in My Stuff as probably this guy, Untitled 2. If you want to give it a name, and I suggest you do, when you look inside of it, the name is right here. So I guess I'll call this CS103 June. What's today? The 6th, the 9th? And now it's title. And now when I go out to my stuff, there it is. Okay. And so it needs to be shared to have anybody see it. That's the important thing. All right. Other stuff to notice about the Scratch stuff. If you, well, I mean, the lab is supposed to walk you through that, and since that's the homework, I'm not going to do your homework for you. So if you have a you want to see a program where it happens. I mean, I can't do that without even showing you the script, I guess. Let me think. So hopefully the lab is meant to help you understand the ways to do that. I guess the hint. All right. Well, let me give you that. Let me. Again, I don't want to do the whole homework for you. So let me go back to my stuff here. Here's the arrow program. And one thing I did want to talk about was that if you take an existing program and you just start messing with it, for example, taking out a thing or whatever, and then you go back to your, and then you leave and you go back to your stuff, what's going to happen is this program, the Cat with Hours program that I was doing, is now changed. You don't need to press save, which in some ways is good because you have to remember to press save, but in some ways is bad because if you do something permanent, like a major change to your program, that major change has happened and you can't get the old one back. Okay? So what I would suggest before you do anything major is to save as a copy before you start. And now what you have is in your My Stuff, you have the original, which you still have in case you want to go back to it, and then the copy that you can mess with. Okay, so let me see if I can do a quick idea about. So this is the arrow program, right? And the cat moves around. One thing that's worth noticing is this button here, the kind of rectangular thing, gets you the whole screen without the script. So you can do the exact same script but on a bigger screen. And then you can minimize it and get the script back. So the way that I would make the other things to hit is I would go into the sprite library and I would pick a couple of sprites. So I don't know if you saw that, but I went inside it. I don't know where it went. There's my ball. And then I went to the sprite library again, and I picked, I don't know, the bat. And so now I've got a ball, and now I've got a bat. You can, I think, right-click the sprite, yeah, and info, is that what I want? I want to make this smaller. Maybe if I double-click it, or that's what I want, the sprite editor. So you click the paintbrush, you get the sprite editor, and then you can take it and you can kind of drag the size of it and make it smaller. Same thing with the baseball. I will drag it and make it smaller so it's not taking up half my screen. And then I go back to the scripts. The scripts are the things that happen. Okay. Now you can either make so that the cat starts doing its thing when the green flag is clicked, and so you have to click the green flag to make things happen. You may want the other sprites to do their thing at other times. You can do it when the sprite is clicked. You can do it when the green flag is clicked. When you do here's how I would probably do it. I would say when the green flag is clicked, forever. And what it's going to do is now forever, what the sprite wants to do is forever look and see if it's touching the cat. Okay. So where's my event? No control. So I put an if block inside the forever. Forever, see if I'm touching the cat. The sensing is going to use touching. You can make the cat and the bat move with the if not a do be command, which I'm not sure what command you mean. One way to make both of them move is to, can I copy this? Duplicate. And can I throw it into there? No. That's a bummer. I want to copy this into the script of the other sprite. But what I could do is this. I could go into the sprite of the ball. Oh, there it is. It showed up like 3 times. Wow. It didn't give me any kind of visual cue that it was doing this. If you press space, then the cat. So here's everything you could do. So right now what I have is 2 scripts that both are forever listening to the key presses. So when I move the arrow keys, both things move in lockstep, right? So your idea, I like this idea actually. So let's throw an if around this stuff and say if it's gotta be the problem with key presses is I'm not sure it's gonna. We'll see what happens. It's a little twitchy about key presses. So this says if I'm pressing the up arrow, just the cat moves. If I'm pressing the up arrow and the space, they'll both move. A good idea, I like this idea, is if not where was that? Okay, key pressed. So now what I got, I like that. This is cool. All right, so the cat says forever if the space key is not pressed and an arrow key is pressed, move the cat. And the ball says if the space key, you can't see me doing it, but I'm actually holding the space key down. If the space key is pressed and an arrow key, move the ball. So I only get inside this change y by 10 or whatever if both the space key is pressed and the up arrow is pressed. And I only get inside that on the cat if the up arrow is pressed and the space key is not pressed. So that's one way to do it. That's pretty cool. So this is a way to move one and not the other based on what key is pressed. It gets a little more complicated if you want to do more than 2 sprites moving around. All right, so getting back to the so the other question was about hitting the goals in order. Here's what I will tell you about that. So now I don't want the sprites to move, so I don't want to have all this stuff in the ball. The ball's not going to move. The ball's going to sit around over here. The ball's going to wait until the cat is touching it. And so cat 1 is touching it. And the first thing I want to show you is touching the cat. So what's going to happen now is I'm going to run this, and the cat moves around. The ball's forever is actually going right now as we speak, okay? And it's not doing anything because it's not touching the cat, okay? But if the ball ever touched the cat, the ball says touching the cat, and then when I stop touching, well, I'll say it for, I'll change this to, forgot it doesn't go away if I don't say tell it to go away. Say touching the cat for 1 second. Now when I run it, ball doesn't say anything, touching the cat. After 1 second, I leave and it goes and does other things. Okay? So this is how you make a sprite wait until it's being touched by another sprite. Okay? The way you do the order stuff, what I would do is I would make a variable called, I don't know, baseball hit. And at the very start of the program, I would set, before the forever, the baseball hit to 0. Remember, 0 kind of means false or no. Okay? And then as soon as you hit it, I can set the baseball hit to 1. Okay? And so now watch the baseball hit variable up here. as I go. Okay, so the flag has been clicked. I run around. I eventually hit the baseball. After I say my baseball hit for 1 second, the baseball hit variable has got changed to 1, which means yes. Okay. So now if I want to hit the baseball before I hit the bat, what I'm going to do is make another sprite for the bat. Same kind of idea. It's going to, when the flag is clicked, it's going to forever wait and listen for things to happen. It's going to say if the bat is touching the cat. Where is my touching? There it is. Then say touching the bat for 1 second. Okay, so this is what I had before. I'm going to do the order stuff in a second. I just want to show you what I've got right now. And it's good to kind of test and make sure your programs work before it gets too complicated. Now I've got a cat, runs around. If I hit the baseball, it says touching the cat. And the baseball hit variable goes up to 1. If I touch the bat, it says touching the bat. And then it turns off. Okay. What I want to do now is add one more step. And that one more step will say, if I touch the bat and I haven't hit the baseball, then do something or not. So what I would do here is use the if-else, which gives you 2 choices. Okay. And what I'm going to do is I'm going to say if the I hit the baseball variable is equal to 1. Okay, so this is still inside the touching the cat if statement. So all this is moving around together. Okay. So after I say touching the bat, if the baseball hit variable has a value of 1, then the only way the baseball hit variable can have a value of 1 is if we hit the baseball before we hit the bat. So I'll do something like, say, correct order. Else, I'll say something like, oops, incorrect order for 2 seconds. Okay, so now what's happening is the bat's always forever waiting to see if the cat touches it. When the cat touches it, we say, hey, we're being touched. Then we see what the baseball hit variable says. If the baseball hit variable is a 1, then we say correct order. The baseball hit variable is 0, we say incorrect order. And that's the program. And that's all inside the if statement. So we do this. So you can kind of see things inside of things and the way the arrow grouping things kind of collect stuff. So you can kind of see that I only say incorrect order in the else, which means baseball hit is not 1, inside the if, which means I'm touching the cat, inside the forever, which means that I'm forever looking to see if I'm touching the cat, and I only do that when the green flag is correct. So I hit the green flag, boom, okay? And I move the cat around. When I make the cat hit the baseball, it says touching the cat. The baseball hit variable has turned into 1, and so if I run over and hit the bat, it says touching the bat, and then it'll say in a second, correct order, hooray. And it also says that I cannot spell the word touching, so let me fix that. All right, if I run it a second time, notice how because I, in the first line of the program here, reset the baseball hit variable to 0, every time I hit the green flag, the baseball hit variable gets set to 0, which means in this run, in this play of the game, in this reset, you have not hit the baseball yet. And if I run around and I do my thing, and I try to hit the bat without hitting the baseball first, it says incorrect order because all right, get away from that. Because I'm touching the bat with the baseball hit variable 0. And now if I run over, hit the ball now, and fix things, and then go back and touch the cat, it all gets fixed because hitting the baseball meant that the baseball hit variable gets 1. So obviously, the homework is more than that, but that's the idea behind how you use the variables to see if you've hit stuff in order. Okay, does that help? Make a little more sense now? Okay, cool. Any other questions about how this works? All right. Do I want to talk about? Probably not. You can also send messages to other sprites, and you can send it, and sprites can receive it. That's another way of communicating between the sprites. I tend to use the variables because I think they're a little bit easier because you can kind of see them change. But if you don't want to have 8,000 variables going around, you want to play around with the idea of messages. Ask. Um, One thing, so other things you can do with this, just to show you, we can make the cat draw things. So what this is going to do is draw the path the cat came in, because this is what happens when I hold diagonal. It goes up. It goes kind of little bits of over and up. It's like an Etch-a-Sketch. So the pen lets you draw pictures. Pen down means start drawing. Pen up means stop drawing. Set the pen color means obviously set the pen color. It's probably not a bad idea if you're doing this to have clear in there so that you can erase all your drawings. I don't know why you'd want to do this for the homework or whatever, but I just think it's cool. So other cool things, there exist things you can do with sound. I don't know if you're going to be able to hear this. Whoa, that was loud. So I've had people in their programs make things crash and make crash sounds when things went wrong and things like that. That was kind of fun. You can change. We talked about changing the costume. We talked about the different events, the control. We talked about doing things a certain number of times as opposed to forever. That's the You can, if you're feeling artistic, also draw your own sprite with the drawing tools. I am hellaciously not artistic, and so this is my attempt at trying to draw something. Woo. It ain't working very well. So if you have better artistic ability than me and want to actually draw your own sprite, you can. Each one of these dots, I don't know if you can see the kind of white and gray dots moving across, is 1 pixel on the screen. And so you can make it whatever size you want by adjusting what you're drawing into those dots. So, boy, this is just so ugly that you are going to die, you stupid drawing. So that's the Scratch stuff I've got. I think you guys know enough to do the lab and the homework. It's going to be hard. It's going to make you try a bunch of different things. So give yourself time to ask for help if you're stuck. But you draw something in the background. Can you give the command to the cat to touch the line and do an action? I don't know what that means. Well, there's no. I mean, do you mean a? I mean, there's no background really. There's sprites I can draw that look like the background. So suppose here's a line, right? That line is now a sprite. See this over here is sprite 1. So anything you do with, now I guess what you could do, well, you could also draw a backdrop. but I'm pretty sure the backdrops, like these things, are not do not have pieces you can interact with. So if you want to, so what I would do honestly is I would make a if if you want to have a background like this, which is actually pretty cool. If you want to have a backdrop like this, what I would do is I would make the backdrop and then I would make a sprite that kind of looks like it's in the background, but it's really not, and then do sprite stuff to it. So that's the way I would handle that. I don't know. I at least don't know a way to make like the basketball hoop part of this a specific different action than the rest of it. I guess what you could do, I think this is a horrible idea. What you could do is go to the cat and say, I thought those were yes. So you could check and see if your X position or Y position is at a certain place that happens to be the X position or Y position of the basketball net, but that requires you to kind of know exactly what the position of the basketball net is, which I don't think you want to do. I think it's much easier to kind of make a sprite and add it in. But there's lots of things you can play with. So yeah, if you get to a point where you want to do something weird, let me know and we'll see if we can figure out a way to make the weird thing happen. So yeah, there's lots of ways to do something cool with this. If this was a regular semester class, I'd probably give you guys a couple of weeks to work on this, and I wouldn't give you that specific homework. I'd instead say make something neat where you can make whatever neat thing you want. But I figured that having a specific thing, a specific goal to try for, would make your life easier since you're doing it a lot more on your own in the online class. So, cool. Any other questions or things? Going once. Going twice. Okay. All right. So the last big topic of the semester, as I try to find my screen, is how to create and analyze algorithms. I've said many times that computer science is the study of algorithms. I haven't really talked much about what it means to study algorithms. Okay. Since a program is just an algorithm written in a programming language, many times the actual programming is not talked about much. You guys aren't there yet, but you can imagine, I hope, that when you get to a certain point of being familiar and comfortable with programming, that the actual, hey, I need to write a program for this, is something that we can kind of assume happens that anybody could do. And the interesting thing, or I guess the creative thing, is the algorithm part, figuring out the solution to the problem and figuring out how to, given a problem, come up with the steps. And then whether you turn those steps into machine language or C++ or Java or Python or Scratch or whatever, doesn't matter a whole heck of a lot. Okay? So a lot of conversations about how to do something often are done not in programming, but in algorithms, which is a more higher level, more abstract way of doing things. Just like we said, a programming language is an abstraction of the machine language, where we hid a lot of the details so we could talk about things at a different level. The An algorithm is an abstraction of a programming language. We don't worry about all of the details of the puzzle pieces. We don't worry about all the details of how the grammar rules of the language looks, and we just talk about the actual generic steps we would take to solve the problem. So, so here's an example of this. Right now, if you have a TV on while you're trying to pay attention to me and try to do two things at once, you may be watching The Price is Right. Which is an awesome game show that I'm sorry my class is on during, that you should all watch at some point. In The Price is Right, there is something called the clock game. In the clock game, there's two people. There's the contestant, and there's the host. The host has the microphone. That's the microphone. We're going to do a slightly different version of the clock game because I don't actually have a clock on me. But generally speaking, what happens is the host shows the price of an item. Well, no. The host shows the item. Usually, because it's The Price is Right, something like a couch or a refrigerator or a jet ski or something that you don't actually need. But the contestant guesses the price. I think that thing costs $500. Okay. After each guess, the host says either correct. Correct means you got it right, go figure, and you win the prize. Okay, that's what you're going for. You're trying to get correct. If you're wrong, he'll either tell you higher, which means the actual price is higher than what you bid, or you bid too low. Okay? Or he'll tell you lower, which means the actual price is less than what you bid, than what you guessed, and you bid too high. Okay? That's the game. Does that make sense? I don't know if you've seen it or not, but it's basically we're trying to guess a price, and the only information we're getting back from after each guess is whether we need to go higher or whether we need to go lower. Okay. In the real clock game, you want to go as fast as possible. Okay. In terms of actual time in seconds, you get 30 seconds to make as many guesses as you can, and that's why it's a clock game, and the clock ticks down. And if you run out of time, then you don't win it. But if you make one correct guess before the time runs out, then you win the prize. Okay. So in ours, because it's hard to do a clock in front of all you guys. You want to guess the correct price in the minimum number of guesses. So I don't know how to do it. So one way to kind of approximate the idea of doing it fast is to do it in less guesses. Okay, so for our version of the clock game, we're not gonna talk about how many seconds it took. We're gonna talk about how many guesses it took. All right, and what we want to do is have the least number of guesses. All right, so here is a bad algorithm. And I'm intentionally not telling you what I mean by bad, and we'll kind of decide why we think this is bad in a second. Okay. Step one: guess $1. Okay. They put out a car or a jacuzzi or something like that, and the first thing I'm going to guess is $1. What I know is if I'm told correct, I win, right? If I'm wrong, I must get told higher. Because $1 is the cheapest it's going to be. They never do cents on The Price is Right, and nothing's going to be free on The Price is Right. So $1 is the lowest possible guess. So the last thing I'm going to do is guess $1 more. I'm going to make another guess. It's going to be $1 more than my last guess. And then I'm going to go back to step 2 and see if I get told correct or higher or what. Okay? So, does that make sense? So do you kind of get the algorithm? Do you kind of get the steps? Could you follow this algorithm and do it? I mean, are these steps that you could perform? Or are you confused by what I'm asking you to do? Hello? Okay. So let me ask it this way. 2 questions for you guys. Maybe 3. Does this work? And by work, I'm saying, will this, aha, that is exactly the right answer. Will this eventually get the right price? So you just answered my question 2, which is this a good algorithm? So but question 1 is, will this eventually hit the right answer? Yeah. Probably not in 30 seconds, yeah. Because I gotta go 1, higher, 2, higher, 3, higher, 4, higher, on and 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 on. And if the thing is like $1,000, I'm probably not gonna make 1,000 guesses in 30 seconds, right? So you guys have already answered this, but question 2 is this a good solution? And what you seem to be telling me is not really. It seems like an awfully large amount of guesses, right? And we can actually quantify how many guesses. If the correct price is X dollars, where X is any number from 1 to, what's the car, $15,000? How many guesses do I make? So if the car is $500, how many guesses do I make? Let's ask an easier question. If the car is if the correct price is $5, how many guesses do I make? With this one, yeah. I'm not asking how many it could take. Yeah, 500 or X, where X is whatever the price is, right? I gotta guess 1, I gotta guess 2, I gotta guess 3, I gotta guess 4, all the way up to X. Okay, so this algorithm takes about X steps, where X is the correct price, and our gut intuition tells us that is probably too many, right? We should be able to do this faster. So, Sean's bold claim. I can pick a price between $1,000 and $20,000 in 20 guesses or less. Probably much less. Probably closer to 15. But I want to give myself some room. So way less than the 20,000 guesses it would possibly take to get it for the crappy algorithm we did, right? So and not only that, I don't even know what number the guess is, but I'm always gonna take 20 guesses or less for any number in that entire range. Okay, so what I want one of you guys to do is to write down and do not tell me a number between 1 and 20,000, and we'll play it, and you're going to tell me higher or lower. All right? So somebody pick a number and tell me that you've done it. All right. What I'm going to do is make a guess, and you're going to tell me higher or lower as we go through, okay? Guess 1, $10,000. Higher or lower? All right. Pick a number that's not $10,000. Pick a weird number that I'm not going to guess off the top of my head. All right, ready to go? Guess 1. $10,000. Again. Am I right again? Okay. Higher or lower? All right. Guess 2. $5,000. Higher or lower? We're correct. Okay. Guess 3. 7,500. So you said lower, higher, lower. Correct. All right. All right. Pick one. I shouldn't erase that. Sorry. Pick one that does not end in 2 zeros. I want it to be like an obscure, bizarre price, like, you know, like 9,734 or something like, you know, not that exactly, but, you know, something weird. All right. All right. Foop. Try again. Guess 1. $10,000. Higher or lower? Guess 2. $15,000. Lower. Guess 3. $12,500. Higher. Guess 4. 13,750. Guess 5. 13,125. Oh, higher. Sorry, I didn't see the higher. Guess 6. 13,500. Lower. Guess 7. 13,375. Guess 8. 13,425. Guess 9. 13,400. Guess 10. 13,390. 13,380. Is that another lower? So it's between 75 and 80. So 13,376, 13,377, 13,378, 13,379. It's either what's one of those. Okay. So 15 guesses. Go me. Actually, 13 guesses. So even with a really weird number that wasn't 10,000 or 7,500 or something like that, I still got it in way, 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 way less than 20,000 guesses, right? What did I do? Let me show you the guesses over again. What sort of strategy was I sort of trying to follow? You kind of see it? Eliminating what? Right. So the cool thing about cutting the numbers in half, at least so after a while, I stopped being able to cut the numbers in half because my ability to do that kind of math in my head went away. But if you think about it, all of the prices have to exist on a number line between 1 and 20,000, right? So if I guess 10,000 and it's in the middle, right? And you tell me that it's higher than 10,000. Not only is it higher than 10,000, it's higher than every single number less than 10,000, right? I never ever need to guess 9,000. I never ever need to guess 8,000. Ever need to guess 7,304. All of those numbers get chopped out for free by one single guess. Okay, so my range of possible correct prices just got chopped in half. Right? And then my second guess, I guessed 15,000. And you told me lower, and so that chopped out everything above 15,000. So now in two guesses, I have a quarter of the possible range of possible prices. And so every time I do that, I chop it in half and chop it in half and chop it in half and chop it in half until I get down to a small enough number that I don't need to, like I get down to these kinds of numbers where I can just list them out, or I get to a point where I can't actually chop it in half because I don't know how to do the price in my head, but I can do it in a relatively small number of guesses. Okay, so there's only 5 minutes left in class. I'm not going to do the whole algorithm here, but things to notice. 1. The algorithm chops the possible range of guesses in half after each guess. It started out 20,000, and then after one guess, no matter what guess it was, there's 10,000 different numbers left. Less, actually, 9,999, but about 10,000. After two guesses, there's only 5,000 different numbers left. After 3 guesses, there's only 2,500 different numbers left. On and 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 on. Okay? Now, what this means is the number of guesses I'll need is the number of times I can chop my initial range in half before hitting 1. Remember what that number is? The number of times I can chop a number in half before reaching 1? I don't know if I made a big deal out of it or not, but I have mentioned it. It's log to the base 2 of the initial range. So, for example, log to the base 2 of 32 is 5, because 32 divided by 2 is 16, 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, and 2 divided by 2 is 1. It's the number of times I can chop 32 in half before getting to 1. Log is the opposite of exponentials. So log to the base 2 is the inverse of 2 to the power of. So it turns out log to the base 2 of 20,000 is, I wonder if I can look that up. Let's see what Google tells me. Log 2 of 20,000. Google tells me it is 14.28. I'm not allowed to make 14.28 guesses, so I round up and get 15. I said 20 because I wasn't chopping exactly in half all the time. I wanted to be safe. Give myself a couple of extra guesses in case the fact that I didn't chop it exactly in half screwed things up. So the last thing I want to tell you is this algorithm is called binary search, and it's super useful. It's a way of going through a set of a lot of stuff in only a couple of checks. It's kind of what you do when you look for a name in a phone book. Not that anybody uses phone books anymore. It's kind of what you do when you have a giant list of things and you want to find the right one in the middle. It's why we alphabetize things, basically, to make things easier to find. Binary search kind of codifies what easier to find means. So on Tuesday, I'll write binary search. I'll write what I did as an actual algorithm whose steps you can follow. But the lab and the homework that I'm going to post for next week talk about binary search, and what they're talking about is this kind of thing. It's called binary search. Binary because we're chopping things in half. Search because we're searching. Okay, so you don't need to know exactly how it works yet because I haven't really told you the exact details of how it works. But does the process make sense? Does the fact that I'm taking a number and chopping it in half, which means I automatically get for free a lot more information than just the single high or lower, make sense? And that chopping a number in half over and over and over again gets down to 1 way faster. So 15 is much, much smaller than 20,000, right? And if I go to 40,000, twice as big a range, I only need one more guess. It's one more chop in half. Okay, so that's the big idea for today. Work on the scratch stuff first before you work on the last stuff. Don't get too far ahead. But by the end of today, everything you'll need to do between now and the end of the semester will be posted on the Blackboard, and you'll be ready to go. All right? Any questions? If not, I will see you guys on Tuesday. Ask me for help when you need help, preferably as early as you can, so that I had a lot of people ask me panicked web page questions on Tuesday, and I would probably have been much more helpful if you would have asked them before Tuesday. But I think I got through everybody's stuff, so yay. All right, I will see you guys